The EPQ total cost formula is a tool for finding the total annual cost of any order size Q as long as you make the stuff. Now, one of the tricks with using the EPQ formula is making sure that it's appropriate to be using the EPQ formula. What is it that we're looking for in a scenario? Well, here's an example. Suppose we must produce 500 of some stock keeping unit annually. Okay, in this scenario it says we actually make this stuff. Now, I'm glad to see that number because that is capital D, annual demand. You might say it doesn't say demand, no, but it says that we've got to produce, meaning we've got to provide, meaning somebody is demanding this stuff. Okay, capital D equals 500. That's a good tip that it's time to use the EPQ formula, but that in and of itself is not quite enough. What are we looking for? And we can produce 50 units a day during our 250 working days each year. Okay, that is lowercase p, the daily production rate. If you're looking at a scenario and it says blah, 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 there's this demand and there's these costs, and they produce at a certain rate. It takes us a certain amount of time to actually make this stuff because we make it ourselves. That's an EPQ scenario. Okay, P is for production. All right, now what else is here? Okay, that 250 working days a year, that's interesting. It costs us $10 to set up production regardless of the size of the, oh, yes, this is capital S, the fixed cost associated with an order. Another good tip about maybe this is an EPQ situation is that very often when we produce something, the order, order up some more, is called a batch because it's something that we make, and you can see that that's the case here. All right, so every time we need a batch of this, we have to pay $10 to a setup is very often what the cost is. There's this fixed cost. Now anyway, what else does it say? It costs us $1.25 to hold 1 unit in inventory for an entire year. That's fantastic, because that is, don't even have to work for it, capital H. Capital H is the cost of holding 1 unit in inventory for an entire year. Okay, found it. Now, what is the question? What would be the annual cost of a fixed batch size, another word for order, of 50 SKU, stock keeping unit? That is asking, what would be the total annual cost if Q, we always use capital Q for the order size or the batch size. All right, what if it's 50? Well, you can see where this is headed. We just need to fill out that formula. It looks like we pretty much have what we need. All right, total cost. Let's see, D. Oh, we found D. D was 500. 500 needed over the course of a year. The Q, the particular batch size that we're investigating, because that's what they asked, is 50. Times, okay, capital S was that fixed cost, that's 10. Plus, okay, great, Q. Again, we are evaluating 50 because that's what they asked. All right, times P. Well, the P is 50 also. Minus D. Oh, wait a minute. Wait a minute. Don't put 500, the capital D. It looks like I don't quite have, I don't see a lowercase d in here anywhere. I don't quite have exactly what I need to fill out the entire formula, because what is lowercase d? It's simple. Lowercase d is daily demand. Capital D is annual demand for the year. Lowercase d is daily demand. Well, it didn't say anything about how much you needed per day. No, it didn't, but it told us enough. I knew we were going to use this for something. I kind of skimmed over that. 250 working days in the year. Remember, with all these inventory models in this chapter, we always assume that demand is constant. I say, yeah, okay, but it still didn't say how much you needed per day. No, but we know that we need 500 over the course of a year, correct? And I knew we were going to use that for something. We're like open for 250 days out of the year. So if each of those days is the same, this is really just logic. It's not a formula. What is that? We're going to need, daily demand is 2, apparently. Oh, that's the number that I need. So this here is 50 minus 2. Then we can continue filling out the formula because that is 2 times 50. And then all of this is times H, which is the $1.25. Okay, now my scratch work, I get that all of this amounts to $130, right? The whole thing works out to $130. Now, that's a year. That is total costs per year. So that is actually the answer to the question that was posed. And at this point, if that's all that we're curious about, we're finished. That is the answer to the question. Now, if you understand, again, the mechanics of this, the underpinnings, like why is that working? Why is that the total annual cost? You can use this same formula. You can break it down to answer a bunch of other questions about making these things 50 at a time. All right, for instance, why is this formula working? Well, it's time for the other tool from this chapter, the Sawtooth Diagram, which is nothing more than a line graph of inventory level over time, in which we watch ourselves using a certain batch size. Now, the batch size that was suggested here was 50, correct? So I'm just marking some point on the diagram. Now, we don't have any of this stuff. We sit down and we start a batch of 50 and somebody works until all 50 are finished. Oh, you know what? I shouldn't have drawn that in ink. Because what is it that I actually sketched here? I sketched them working on the batch, starting at nothing and stopping at, that's supposed to stop like at the 50, right? Made a batch of 50, shut off the machine, we are done. That's not the same thing as inventory level. This that I drew in blue ink is actually cumulative production. And so yeah, it's somebody working on the batch of 50 until they're finished. Yes, that's not the same thing as inventory, because remember our assumption that demand is constant? That means even if somebody is working on a batch of 50 of these things, somebody else is using this stuff at a rate of 2 a day. That means that the actual inventory levels do climb as they work, but not as fast as their actual production rate, because somebody in the meantime is using this stuff. Oh, meaning that inventory doesn't peak out at exactly 50. It peaks out at something somewhat less than that. But at any rate, they finish the batch, they stop working, and then we just coast. We coast on what we have in inventory until we run out, and then they get going again, they make another 50, and then this is what the teeth look like in this sawtooth diagram. Oh, of which you can see a much prettier picture down here from the book. Right, in this particular situation, you can see that each tooth is basically broken into 2 phases. This is where somebody is busy working. The length of that amount of time, you can see here pointed out, is the run time, right? How long it actually takes for them to make a batch. And then the rest of the diagram, like this part right in here, is where we're just coasting on inventory. Oh, all right, but still the overall area of that triangle is basically proportional to the inventory burden. Each time a tooth kicks in, we pay that fixed cost S. Now, wait a minute. What's this business about? If I understand this, I could answer more questions about my policy using the same formula. This is the formula right here that we filled out for Q equal 50, right? We said, oh, well, the total cost is $130. This half of it is the setup costs annually. This half of it is the holding costs annually. So if you look into your scratch work and somebody wants to know just what the inventory holding costs would be, you can report just that half of the formula. Now wait a minute, there's some other questions down here. Number of orders annually. Look inside this first half of the formula, cover up the S. Yeah, that's D divided by Q. Because, think about it, it's kind of logic. You need 500 over the course of a year. You're going to make them 50 at a time. That was the proposal, right? That's what we're evaluating. Well, it means that you'll have 10 orders a year. You'll set up and make this stuff 10 times a year. There'll be 10 batches in the course of a year. Oh, okay. Maximum inventory level. Oh, now in the EOQ, the cousin of this particular scenario, maximum inventory level was easy because it's just the size of the order. Here it is not so easy. Maximum inventory level, what's the most of the stuff we'd ever have to store? It's going to be something less than Q. How much less? Now, first off, I can just give you the formula and you think, oh gosh, that just sounds like something I'm going to have to remember. We are maxing out at Q times P minus D over P. So first off, fill that out. That is the 50 times 50 minus 2 over 50. So I get 48. All right. Right. Actually, I probably didn't need a formula just for that particular question because let's think about it. We're making these things 50 at a time. Our inventory is maxing out at 48 because we can make them at a rate of 50 a day. Remember that? Which means it only takes us 1 day to make a batch, which means that daily demand was 2. Oh, right, 2 of them would have been carried away. But anyway, that's only because of this particular problem. That's the formula for maximum inventory. Average inventory is right here. If you have the total cost formula, you don't have to memorize the formula for average inventory because just cover up the H. That is the formula for average inventory. Now, fill out that formula. 50 times 50 minus 2 divided by 2 times 50. You'll get that the average inventory is 24. Now I want to point something out. Maximum inventory was 48. The average inventory for this policy is 24. Do you notice that the average inventory is half the maximum inventory in this particular situation? Tip. It's not this particular situation. It's any situation in this kind of scenario that the average inventory is always half the maximum inventory. The maximum inventory is always twice the average inventory. So if you had this formula, you know to go into this half, cover up the H, that's average inventory. Then if somebody asks you, well, what's maximum inventory, what's the most we'll ever have to store, just double that answer and you have maximum inventory as well.